This is TWIS. This Week in Science, episode number 827, recorded on Wednesday, June 2nd, 2021. This is a periodic science show. Hey everyone, I'm Dr. Kiki, and tonight on the show we will fill your head with hearing, new limbs, and magic tricks. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. Not everything you don't understand is the first thing you think it might be. As UF news abounds, a few things to remember. Nothing has been discovered. Yes, there are instruments giving results that don't make sense, but they only don't make sense if you assume you know what you are seeing. Yes, there are eyewitness accounts that seem credible. They come from humans trained to track vehicles in flight. So, as far as vehicles in flight are concerned, nothing makes sense. Sure. So, but that just maybe means they're not vehicles in flight, that they're just objects. What we do know is that objects are falling from over 80,000 feet in the sky, according to the missile cruiser USS Princeton that tracked hundreds of such objects over the course of the week the footage was taken. And they are very, very cold, as shown in the infrared camera on the Super Hornet jet fighter's sensory display. That's all we know for sure. It could just be re-entering space junk from cluttered and decaying cloud of millions of pieces of space trash we've littered in our low orbit. But to be fair, I guess it could be falling space junk from E.T.'s mothership that we blew up with our secret moon base laser. But I'm skeptical of that second idea. Also, hey Pentagon, if you had to spend $22 million to look into this, maybe pay scientists instead of whoever you got that didn't give you an answer yet. Because you would likely have an answer by now, and that answer would no doubt be This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again. We're going to talk about science. We've got lots of it. And no, Justin, we're not talking about UFOs tonight. No, we're talking about science. Okay.
Oh, well, you could do both. It's
just putting it out there. Just putting it out there. It's all about science.
Aren't they UAPs now? Unidentified aerial projectiles or something?
Yeah, thank you very much, Blair. There's a new terminology even. But for those of you who are joining us for this episode of Science-y Goodness, I brought all sorts of fun stories, and I know Justin and Blair did as well. I've got some NASA news. I also have dark matter mutterings. I've also got bat people, and I've got neuroscience because, I always love the brain stuff. So some intelligent pupils and fast memory will close out the show for me. And we have an interview tonight on women, menstruation, and the COVID-19 vaccine in just a little bit with doctors Kate Clancy and Katherine Lee. Justin, what did you bring?
I've got, I always forget how to say them. Axolotls?
Axolotls?
Axolotls.
My son asks a lot of questions.
I got some axolotl news. Some medical health news. I've got some. I've got a new segment for the show called "Did We Really Need a Study to Tell Us That?"
I think I might like that. All right.
And then, if we haven't run out of time, human brain and testes found to have something in common.
I would love to know what that is. I guess we will just have to wait. Blair, what's in the animal corner?
I have why YouTube is bad for exotic animals.
Okay.
I have electric fish and very purposeful pauses. And also, I have Eurasian jays and whether or not they enjoy a magic trick.
Birds of a feather, like magic?
Together.
Together. Yeah. Yes. Okay. All right. We will find all of this out in this episode of This Week in Science. As we get started, before we jump in, I want to remind you that if you are not yet subscribed to This Week in Science, look for This Week in Science on YouTube, on Facebook. We're also on Twitch as TWIS Science. We're on Instagram as TWIS Science. You can also find us all the places that podcasts are found. Look for This Week in Science. Our website is also twis.org. Okay, let's dive in first with NASA news. Boop, boop, boop. I just made up that little jingle. Okay, NASA made headlines today. I mean, NASA on its own makes a lot of headlines for the amazing things that it does, but our space agency in the United States today made headlines because it announced that a selection for the Discovery missions to Venus. They selected 2 missions to go to Venus. They will be slated for launch in 2028 to 2030. The Da Vinci Plus mission will investigate the planet's atmosphere, looking for signs of life. That's right. They're also going to search for evidence of past oceans and take pictures of tesserae. And if you don't know what tesserae are, they are continent-like formations. They're trying to figure out whether or not Venus at one point or maybe currently has plate tectonics. Additionally, the other mission is the Veritas mission. It's going to study the geologic history of Venus and check to see if currently there are active volcanoes spewing water vapor into the atmosphere and continuing to add to the thick greenhouse gases that maintain the Venusian skies. Also, moving on from these 2 missions, the one not so exciting piece of news that came out this week. Guess which space telescope got delayed again?
Is it the Webb? Because that's the one that's always getting delayed.
It has been delayed since 2007. It was supposed to launch in 2007. That was the original launch date. It's now bigger and better. Its budget got a lot bigger. But it's supposed to launch October 31st of this year, but for multiple reasons, they have to get the telescope packaged and all the way down to French Guiana. They can't
find large enough mirrors. It's a whole thing.
It's a whole thing. COVID.
This isn't just like one of those don't let the perfect be the obstacle of the good or whatever the saying.
Yeah.
Like I get that. The thing that you designed in the 2000s, early 2000s, isn't as great and powerful and amazing as the thing you could design in the mid.
No, they've added to it. It's got other updated bits.
But
it's
at some
exciting.
point, it's like we can send another thing sometime. Just send what you've got now. Otherwise, it's just you can keep building the better.
Well, just imagine though. Just imagine if somebody was building you a cell phone, right? In 2007.
Right, it's going to take them 2 years.
And then but I'm saying now. They try to hand you the cell phone that they started making in 2007.
Yeah.
You'd say, what am I going to do with this?
Useless.
So I understand what you're saying, but I also think they have to adapt a little bit because what they started with is obsolete.
Right. No, it is.
But
and it's funny it's how quickly we accelerate with our technology now.
Yeah. But at this point, the Webb is going to take the place of the Hubble Space Telescope. It's going to be bigger, better, give us more amazing pictures of the universe. Yes. And wouldn't it be awful if the rocket that we were using, that the fairings failed and the whole James Webb Space Telescope mission just boomed at this point? Like, you don't want explosions at this point. They might have a backup, but they want everything to be right because at this point we don't want to lose what we've built.
Yikes, I don't want to be holding the joystick on that one.
They've said maybe it'll only be delayed for a couple of weeks, but you never know. Never know with the James Webb.
I know it's NASA, and I know they go have some extreme elements that they have to deal with in the engineering and the design and everything else. But then when it comes down to the manufacturing aspect of it, can't you just build 2 at that point? And it's just...
They might have. Sometimes they do build 2.
Yeah,
but this one is big. So I don't know if they've been able to. Anyway,
engineering tinkering that goes on before that takes.
Anyway, the James Webb can't re-engineer itself, but Justin, you have some regeneration news, possibly?
Oh, yeah, it's limb regeneration or tissue regeneration, organ regeneration, whatever you want. Whatever you want, we can do it now.
Whatever I want. I want a new liver.
A jar of stem cells? Is that the idea?
Just how's this going to work?
So a limb regeneration generally is not a thing that people think too much about. Like, we don't I can't regenerate my limbs until you lose one. And then you probably think about it quite a bit more. Mm-hmm. It's the thing that makes salamanders more advanced than humans. I'm going to mess it up again. Axolotl?
Yeah.
Axolotl salamanders can regenerate pretty much anything that makes up an axolotl. The brain can regenerate. Heart, limbs, jaws, all the rest of it. Spinal cord, skin, tail, that's easy stuff. Any of it. So there's a team of scientists led by James Godwin, MDI Biological Laboratory, Bar Harbor, Maine. And he's got an idea that's got some legs to it about how we might be taking a step closer to maybe how figure out why it is that we can't regenerate and maybe how we can in the future. So instead of regenerating, what mammals do is we get scars when something gets damaged. The little tissue, the macrophage signaling. Macrophage being it's the phagocyte system, the white blood cell part of the immune system that goes in and kind of fixes some stuff up and tells it, okay, you're going to be a scar. But an axolotl don't scar. They instead generate. And it seems like they have macrophage involved too. So what they did is they checked axolotl with mice. Mice can actually do some level of regeneration. And they exposed them to pathogens, bacteria, funguses, viruses, this sort of thing. And they looked to see what the white blood cell macrophage did. And its response was similar in both. It seemed to have the same types of responses. Then they induced injury. And that's when the macrophage signaling became very different. And the axolotl, it promoted growth of new tissue immediately, while in the mouse, it began promoting scarring tissue. This is quoting Godwin. Our research shows that humans have untapped potential for regeneration. If we can solve the problem of scar formation, we may be able to unlock our latent regenerative potential. Axolotls don't scar, which is what allows regeneration to take place. But once a scar is formed, it's game over in terms of regeneration. If we could prevent scarring in humans, we could enhance quality of life in so many people. Seems like a stretch, but there are instances of human regeneration. It's like the liver does some weird stuff. But embryos can regenerate. Human infants can regenerate heart tissue. Children can even regenerate their fingertips, which is the thing I did not know, but do not suggest anyone trying it at home.
Yes, so if I can interrupt really quickly, yes. I was hoping you were going to bring that up, because the thing about the axolotl that I think is really important to point out here is what makes them look so weird and different and special is that they are essentially a salamander that is stuck in the juvenile phase. So salamanders have gills when they're babies, and they stay underwater the whole time. And then salamanders come out onto land, and the gills, they lose them when they get older. They metamorphose. So these guys are what's called paedomorphic. And so basically they're stuck in this juvenile phase. So that scientists have always thought that has something to do with it.
Yeah. No, that might be part of it. That might be a part of it. Specifically, this paper did go down into mechanism a little bit. They reported the signaling response was in a class of proteins called troll-like receptors, TLRs, which allowed macrophages to recognize a threat such as infection or tissue injury and induce the pro-inflammatory response. And that's where it became very divergent in that response between axolotl and mouse. So the thing is, if there's that mechanism is in a mammal and it's in this juvenile axolotl, it may be that it's still accessible after a bit of tinkering, or perhaps with a bit of fakery, some sort of pharmaceutical-induced, chemical-induced something. So, quoting Godwin, we are getting closer to understanding how axolotl macrophages primed for regeneration, which will bring us closer to being able to pull the levers of regeneration in humans. For instance, I envision being able to use a topical hydrogel at the site of a wound that is laced with a modulator that changes the behavior of human macrophages to be more like those of axolotl.
I mean, maybe we'll get rid of more scars, but I mean, I don't know if this is a maintaining juvenile traits. Is that meaning that if you lose an arm and try to regrow an arm, you're just going to have a baby arm?
Oh, no.
Yeah.
Is it going? That is the question. I mean, how long will it take to regrow? What are all the details? There's nerve connections that need to be made with the brain, and there is so much more that is beyond just fixing the growth part. But I mean, I guess you figure out one step and you can put them all together. But
if we could get the dermal regenerator from Star Trek, I think that would be very helpful. That would be very
helpful.
Well, but if it's also, though, if this is also something that can be utilized in organ tissues, if this can be utilized, then you're talking about getting away from every sort of transplant, all this the world of technology that has been going down those lines, trying to perfect that. If we can just get the body to fix itself, because it has the plans. The body knows where everything is located. It's got the blueprint. It's got the materials to do the building with.
Blair, what do you have up next?
I have a real quick story just about YouTube and how it's bad. No,
do not mock our digital overlord.
No. It's actually something that I often yell at my phone about when I'm scrolling on YouTube or Instagram or any number of social media profiles or platforms. But it's about sharing videos of exotic animals put in a pet trade setting. So this is from the University of Adelaide. They wanted to look at the reactions of people on videos on YouTube. They did choose YouTube because it has the most number of these videos and is covered in all 6 continents. And they wanted to analyze reactions to 346 popular videos starring exotic wild cats and primates in, quote, free handling situations, which just means humans are in contact with them. There's no barrier between them. And they looked at views between 2006 and 2019. And the long and short of it is the majority of reactions were positive. They were positive emojis. They were comments like, isn't that cute? And then other indicators that they wanted to be close to the animal and that they wanted to have similar interactions of their own. And this is a good pulse checker for how people feel, but it also promotes, it's kind of like that echo chamber, right? It promotes this narrative that exotic animals are cute and could potentially be good pets. As we know, most exotic animals in the pet trade are taken straight out of the wild. They're not even bred in captivity. A lot of them die in the process of getting put into captivity, and wild animals are not pets. They are not domesticated. They are not suited for it. And so not only is it affecting wild populations, but a lot of the time they are not well suited. The only kind of positive thing that I will throw in here is that they did see a dip in positive comments in 2015, and they think it was related to the Tickling is Torture campaign. So if you've seen videos of slow lorises, you might see people tickling them and they put their hands up and it looks like they're smiling. They're actually grimacing. They're not enjoying it. And slow lorises die in captivity, often from stress. Their stress hormones are off the charts. If you check it out, it's not a good situation. And so when there was an active social media campaign called Tickling is Torture in 2015, these dropped. So the long and short of it is, if you just put cute videos out, people are going to like it and it's going to glamorize the process. But if you can pair it with education, it can actually go a long way. And the other thing they noticed was that these policies in social media don't cover exotic animals as pets as a bannable or censorable subject. And that is a problem, because if you don't have rules that that prevent something akin to animal cruelty. You can ban videos for animal cruelty, but they don't count exotic animals as pets as animal cruelty. So that is another area of improvement here. And I'm one of those people, I'll tell you right now, people watching might hate me for it, but I report every one of those videos that I see. Because if you look at the comments, they're all, I want one, I want one, I want one. Where did you get it? Gosh, where can I get one? So this is an important moment to remember that even the silliest social media video has a moral obligation to make sure that it's not harmful.
I think that's a really important point. There are a lot of accounts on Twitter, on Instagram, on TikTok that just copy cute videos and share them, or cute images and share them. And people are like, yay, I love that. Yes, yeah. But as a science communicator, if we can get the message across that if you're sharing a video like this, maybe put the reality of the situation. This is a wild animal, and maybe post things not only in the description, but actually if you're making the video, in the video itself, so that it's something that can't be overlooked if somebody thinks it's cute. You think it's cute, but this is a wild animal. You don't want one of these at home.
Yeah. So algorithms could be better. AI could be trained to kind of flag and double check these things. So, yeah.
We are going to move out of our first opening stories and into our interview in just one moment. Yes, I want to remind everyone this is This Week in Science. And if you are really enjoying this show, really, are you really? Please tell a friend. Share it with someone else today. Okay, it is my pleasure to have our guests join us tonight. Our guests tonight on the show, Dr. Kate Clancy and Dr. Katherine Lee. Dr. Clancy is a biological anthropologist who specializes in reproductive health at the University of Illinois in the Department of Anthropology. Her additional research and policy advocacy work focuses on sexual harassment in science and academia. Dr. Lee is an NIH-funded postdoctoral research scholar in the Division of Public Health Sciences at Washington University School of Medicine in St. Louis, who also works as a biological anthropologist, but with a focus on reproductive bone health. Thank you, both of you, for joining us on the show tonight.
Thanks for having us.
Yeah, it's great to have you here. For the conversation tonight, I told everyone last week that I was inviting you here so that we could talk about women's reproductive health and also the COVID vaccine and its effects on menstruation and whether or not there's anything known about that. But before we dive in, Dr. Clancy, can you just give us a brief overview of what is biological anthropology? And in your website, you also say that you focus on reproductive ecology. Can you talk about these fields and how they work together?
Sure. Biological anthropology is a pretty large and diverse field with a bunch of subdisciplines. There are people who study biomechanics and like how it is that we move. People like us who study things like hormones and biomarkers and menstrual cycles. We've got folks who dig things up and look at bones and fossils. People who study primates, folks who focus on immune health. But what really unites all of us is that we have at least some evolutionary lens to what it is that we're doing. And so we're taking kind of, even in a lab like ours that studies modern humans and is, sometimes only cares about, say, 28 days of what's happening in your life. We take a really long view and think about human evolution in a really big way. Reproductive ecology is a field that specifically looks at environmental stressors and how they affect reproductive functioning. And for us, obviously, we care about this specifically among humans.
Okay, so it's really digging into kind of how we interact with the environment and the ecosystem. Dr. Lee, how did you come to become interested in biological anthropology? And how did you started working with Dr. Clancy? How did that start happening?
Yeah, so I sort of accidentally stumbled into biological anthropology. I just happened to take an anthropology class while I was doing prereqs to apply to medical school because I thought I might want to be a doctor. And the university that I was at had they didn't prorate any of the fees that you have to pay when you register for classes, So I was like, I'm going to get my money's worth and take an extra class because I'm thrifty like that. And so I took an introduction to anthropology class, and a lot of the stuff in the biological anthropology section really struck me as the way that I wanted to think about health more broadly, thinking about the ways that the ecosystems around us impact our health, thinking about it through evolutionary lenses and comparative lenses, and the different ways that culture can interact with biology even. And so I took that class, and then I still had more prereqs to go. So I just kept taking more anthropology classes, focusing on bioanth. And I ended up applying to work with Dr. Clancy for my PhD, and 7 years later, defended it last year.
That's amazing. Yeah, I understand those chance classes that you take, and suddenly you're like, wait a minute, this is really something amazing. How did you, Dr. Clancy, how did you get interested in biological anthropology and what you do?
A really similar story. I was taking a gen ed course, and students loosely just called it sex because usually it was taught by two white men who would say really essentialist and problematic things about humans. But I was like, I got to take this B core curriculum, so I got to take this class, and I really hated it. Really hated it. I was there with my boyfriend at the time, so I would go with him, and it was just a terrible experience. And it was at the very end of the semester that, after dealing with all of this essentialist, sexist, messed up stuff where it's like boys are like this and girls are like this, the very last class, one of the instructors, the more senior of the two, gave what was this amazingly feminist lecture about the ways in which the academic glass ceiling is reinforced with concrete. He talked about problems with public breastfeeding and how breasts and breastfeeding are sort of these normal ways of feeding humans. And why is it that we have he said all these things that basically completely contradicted the jerk he'd been all semester. And yet it really moved me. I'd never, ever had a man stand up in front of me and say anything strongly feminist or supportive. And so I literally cried, wrote him a super dorky email that was like, I'm going to be a biological anthropology and women's studies major. And I'm old enough that he looked at my dorm phone number and called me. I don't know why, but he called me and he was like, you should definitely do it. You seem like someone who really cares about this stuff. You should do it, but you should drop that women's studies thing. Which I did.
No.
Yeah, exactly. So maybe he wasn't the feminist ally that, maybe all of the other classes should have clued me into the fact that he wasn't actually that much of a feminist ally and actually really said hostile things about women's studies in that call. But I did it anyway. And I double majored in biological anthropology and women's studies. So that's where I got my start.
That's a wonderful story. It's again, it's like these places you don't expect that inspiration to come from, and that's how you get involved in it. For anthropology, I think I've always thought of it as going and digging up old pieces of pottery and bits and pieces of, the remains of humans, finding out how we have lived or how we live. But I have never really put it together with this biological aspect of how we interrelate with the ecosystem and how that all works together. Can you talk a little bit, Dr. Clancy, about how you're working in your lab now with respect to COVID and how has that changed any of the questions that you're asking and how you ask them?
COVID shut down our lab because, one of the things that's really important to us is prioritizing people over the science that we do. And we really care about the human beings who practice science and the human beings that we engage with as participants. And so early on in the pandemic, we just completely shut down. And we haven't actually really opened back up yet because we have a very small lab and it would be really hard for us to have multiple people in there at once. So we've had some folks in there doing some aliquoting for us to ship samples elsewhere to a lab that's large enough and has the appropriate safety protocols that the samples can be run there. And we do certainly hope in the coming months, we just had a safety audit this week actually, that we're slowly going to be, if and when we have samples, which we hope to actually early next year, that we will actually sort of start doing things again. But yeah, we completely shut down a lot of data collection and processing of biological samples. But thankfully, we also happened to be at a stage where we were wrapping up a bunch of that kind of work and we're really moving into the analysis and writing stage. So it wasn't actually as hard of a decision as it would be for, say, a more experimental lab where you have to keep cells alive and running experiments and if there's a break in that, there can be a real problem for the science that's being done.
So what are the majority of the types of samples that you work with? So if you're working with phylogenetic analyses, are you working with genetic? Are you working with saliva samples? What are you working with?
Personally, I work with a lot of pee.
Yeah.
So lots and lots and lots of pee, and some blood, but mostly pee. For the studies that I've done with Kate in her lab, it's been a lot of going around and asking strangers if they would like to participate in this study, and could you collect your urine every day for a full menstrual cycle and stick it in your freezer, and then we'll pick it up later. And so for each person, you end up with somewhere between 20 and 40-ish samples of pee, and multiply that by 100 and something people. And that's how I spent the last few years of my grad career.
Feeling the stinky pee.
It's better than spit, though.
It is. Pee, spit is so much. For my dissertation, most of my work was spit. Only a little bit was urine. And oh my gosh, morning breath is like, it is a thing. And it is when you go and it's floppy. You have to vortex it to get all the particulate to the bottom. And then like the morning breath smell when you uncap it. And it's actually way worse than pee, I think.
Whoa. That's mind-blowing, but also makes a lot of sense.
Yes. Scientific horror stories. The research that has to happen.
Ever had that person just had asparagus moment in any of your research, since you worked with so much more pee than me?
I've had this person was probably out drinking. They're really dehydrated. A few samples.
Yes. Oh, wow.
No judgment, just science, just doing the work.
Let me just write this patient a letter. You need to drink more water.
Dr. Lee, you're working with urine samples, or you did work with urine samples. Is this looking for hormone levels? What are you what are you mostly working with?
So part of it was to look at hormone levels for things like estrogen metabolites and progesterone, those like ovarian hormones that vary across the menstrual cycle. But also we looked at daily values for a lot of inflammatory biomarkers and a couple of energetic biomarkers. And then a couple of days, I looked at some markers of bone turnover. So thinking about bone metabolism, but that wasn't an everyday. It was just a specific couple of days.
Are you doing the same kinds of analyses, Dr. Clancy?
I don't. I'm sort of at the I get to write things stage of my career. So I haven't had to smell pee or spit in a really long time. And in fact, the statistics that my students now run exceeds my own capabilities because they tend to program in R, and I never really learned R. So I get to do more of the big picture stuff. A lot of my work is, in terms of the research questions, yes, a lot of my work focuses on inflammation and the ways in which inflammation in the immune system and immune challenges are sort of can affect things in the menstrual cycle. And then we also have a lot of work because of, as Dr. Lee pointed out, even though sort of there's this big picture question around evolution within biological anthropology, the other big question is obviously culture is something that becomes biology in all sorts of very real ways. Systemic oppression affects the body. Sexism, racism, these are things that actually become embodied in very real ways. And so understanding and studying structures and culture is actually a really big part of our lab too. And so that's a lot of what we've been doing a lot these days as well, studying science cultures, but also trying to better understand psychosocial stressors and the ways in which systemic or structural oppression can affect psychosocial stressors. And then those in turn might play a role in affecting the menstrual cycle as well.
Oh, there's so many layers to peel back to determine how things work together. As a trained physiologist, I'm like, just how the body works, the system of the body itself. But now you're taking this additional step and adding environment, stress, how that influences the hormones, how that influences the body. And I imagine that would also influence back into the society itself as a feedback loop of if individuals are chronically stressed and chronically, if their immune systems are chronically under stress, then they're going to be more sick, maybe have worse responses to stressors, to inflammation, to other things, and end up in the hospital more often, or maybe responding differently to medicines. So many different layers. So this brings us to COVID, and the study that you're currently working on is this question of whether or not that not COVID-19 itself, but the COVID vaccine or vaccines, whether or not they affect the menstrual cycle. Can you tell us how you came to start thinking about this question and start looking at it and designing your study?
It started from sort of personal experience for me, for a friend that I was in close contact with who got vaccinated the exact same day as me. And we were just sort of in conversation about, oh, how sore is your arm? Do you have a headache? Did you get a fever? And then a couple of days later, we were both like, I'm having like period symptoms that are way worse than I would normally have. And the other one was having the same response. And so I reached out to several other people that I knew were nurses or something like that who would have been vaccinated on the earlier end and just asked if they'd noticed anything. And then I reached out to Kate to see if she'd heard anything or had any thoughts about specific mechanisms for either the vaccines or inflammatory processes associated with vaccines. And she sort of said, nope, I haven't heard anything, and shelved it until she had her shot. And then I'm sure you've seen the Twitter thread that she wrote about her experience. And so then that day, we started talking back and forth on Slack and drafted the first version of the survey and went through some revisions and human subjects and got it up in April.
Do you want to add anything, Dr. Clancy?
Just that I think it's important that this was something that I'm trying to figure out like a nice way to put it, but just so that I guess the angry part of me would say, you know, there are ways in which the lived experiences of people who menstruate or people who have menstruated in the past are historically overlooked. And it takes people who have those lived experiences sometimes to, and then also happen to have that scientific expertise to notice things happening in their bodies. And so what I think is really remarkable about what Katie first observed, what Katie brought to her colleagues and brought to me, is that, you know, sometimes it takes actually having those bodies that can have these specific things happening to them for it to occur to you to study it. Because there are no menstruation questions asked or menstrual cycle questions asked in any American vaccine trials. And in fact, vaccine trials historically remind women, I mean, women have only been a part of vaccine trials since the 90s anyway, but now that they allow women in vaccine trials, they advise them to try not to get pregnant. And so usually they are advised to potentially get on hormonal contraception, which is also then potentially going to mask menstrual side effects.
That's fascinating. It's fascinating to me. I mean, that no doctors at any point have asked, did you have any menstrual symptoms or any changes? You know, that question has never been asked since the 90s when we were allowed into menstrual vaccine studies. It hasn't been asked or studied.
There was a little bit about the HPV vaccine, though my understanding of most of that is that larger scale studies showed no real effect there, though I'm by no means an expert. But certainly, and Katie, you can speak to this too, we spent a lot of time looking at the literature trying to find anything on this. And we found a lot of inferences we could make, especially because of our expertise literally studying inflammation and the menstrual cycle. And there's a huge literature on, there's a small literature on vaccines and how they affect bleeding. There's a decent sized literature on bleeding changes and how they affect heavy menstrual bleeding. And there's a decent literature on how inflammation affects menstrual cycles. So there's a lot of pieces you could put together that with just a little bit of expertise, you can immediately notice that there's actually something going on here, but no actual study that we could find that actually looked at these things together.
Yeah, and there was an article in The Scientist that went on to, I think it quoted Jen Gunter saying in her Substack newsletter, the COVID-19 vaccine is not capable of exerting reproductive control via proxy. Nothing is. So I read that and I kind of was like, wait a minute, but the immune system doesn't, and stress cycle and so many things do have an impact on the menstrual cycle. And so by proxy, a vaccine could. And so I was just really kind of taken at this blanket statement that there's no way it could have an effect. Can you tell us a bit of the work that has been done or some of the evidence that, you know, how does inflammation affect the menstrual cycle?
Sure. So the main thing is that the uterus is a site of tissue remodeling. So speaking of, you were talking about axolotls earlier, right? We have, out of our lab, we have 4 papers with a collaborator that actually looks at tissue remodeling and the endometrium. This is another thing that we do actually study in our lab. And one of the things that's fascinating about this work is that, think about the one place in the body where stuff is constantly grown, differentiated, and shed, and then you do it again and again and again, about 400 times over the course of your life. And also that happens to be a tissue that makes human beings. And yet, until like maybe 10 years ago, most tissue engineers, it didn't occur to them to ever study the uterus as maybe a means through which we could better understand tissue regeneration, angiogenesis, vasculature, all the kind of stuff.
Vascularization.
Right? Yeah, you'd think the corpus luteum, which is that yellow body left behind after ovulation, that is the most rapidly vascularizing tissue in the entire body, would be something that some tissue engineer once upon a time would study. That's a free dissertation for you because nobody's looked at it yet from a tissue engineering perspective.
Wow.
So that's really the biggest thing is that tissue remodeling is inherently an inflammatory process, right? There's all sorts of cytokines and chemokines and MMPs and all sorts of, I could throw a lot of acronyms, but what's more important is just understanding that you can imagine that when remodeling has to happen, there are both pro and anti-inflammatory mechanisms at play that are allowing that tissue to grow and differentiate and modify into something useful for the body. And so these are things, this is a very well understood process that's been known for multiple decades. There are lots of people who've been studying this and studying sort of trophoblast invasion, right? The processes of fertilization and pregnancy. And so, there are a lot of ways by which during the growth phase, during the differentiation phase, and during the sloughing off phase in the endometrium that you might expect that a major immune challenge that creates a large inflammatory response might in some way affect the communication happening in that system at the same time.
And is it just an ongoing thing, or is it just during that sort of recovery from the immune system adjusting and coping with the vaccine?
So we don't know yet because we're still designing the follow-up studies that would allow us to look at sort of 3 months out, 6 months out. But certainly anecdotally, I would say that this is a 1 to 2 menstrual cycle thing from what we can see. Just because that's how, if you think about it, it makes sense that the body would work that way, that a current acute stressor would have an acute effect on the body, but that it would not be long-term. Because if that were the case, then anytime we had an immune challenge, it would have some kind of permanent effect on our menstrual cycle. And we know that's not the case, right? Except in like very major chronic issues, like an autoimmune disease or something like that. Maybe there's a connection there. But in a short-term acute immune challenge, you're going to see a short-term acute effect.
So I guess the thing that I think is really challenging here, and I think part of the reason that Jennifer Gunter kind of said what she said in that article, is that I feel like we have these two kind of fighting sides dealing with a public that doesn't fully understand women's bodies.
Yeah.
Just basically, right? So you have this awesome thing that you're studying that's really interesting. But then on the other side, you have a misinformation campaign telling people that the COVID vaccine will make them infertile. So I think how do you bring this to the public? And I saw both of you are pretty active on Twitter, right? So you're trying to bring stuff to the public related to women's health and menstruation and your current research consistently, right? So how do you bring this to the public without accidentally fueling this misinformation machine? Because I could see how this headline could be run with in the wrong direction.
I think largely being very respectful of the public and meeting them with kindness when they have these fears. Like, I think a lot of people think about their menstrual cycle as something that is a sign of their ability to get pregnant, even if maybe that cycle they didn't want to get pregnant anyway. And sometimes a lot of messaging around fertility and menstruation isn't maybe the most accurate. So people think that like disrupting the menstrual cycles, one, like we said, we think it's very temporary. But people think, oh no, it's going to impact them forever. And that's just not likely to be the case in any way, shape, or form. And I think a lot of the pushback that people like Jen Gunter has been trying to mediate and navigate is the fact that, yes, there are mechanisms where we would expect to see a change in a menstrual cycle, but it is not affecting your like reproductive capability in any way, shape, or form. You know, we've had people contact us to say, my period was late. It's so late. It was so late. Oh, I got pregnant. Never mind. Like
more than once.
That'll do it. Yeah.
About our study where they were just like, I would like to let you know it's not that my period was late because of the vaccine. But I think just being kind, trying not to make people feel dumb or ridiculed, but bringing the information to people who are just trying to make sense of their body and understand what's happening is just a huge amount of work and labor, but I think it's really worth it to be able to make that difference.
It's just sort of interesting, though, is like, as I kept thinking, like, wow, it's because everything was rushed out that, you know, these trials happened so fast, and then it was such an emergency situation that we would have known about this a long time ago if it wasn't rushed out. But from what I'm also hearing, like, no, we would not have. We would still have. In fact, if it wasn't so many people getting it at the same time, we might not know at all.
I can tell you, I was in a vaccine trial, and there were no questions about my period whatsoever.
Wow. So it's just,
and we've heard from people who've tried to, they've participated in vaccine trials, tried to get it so that they like have said that to the person they're meeting with, hey, I'm having these side effects. My period is like bananas or whatever their thing is. And they just say, oh, you're just stressed out. And then don't report it. They don't put it in.
Just fanatical woman.
But yeah, no, this would not have, if it hadn't rolled out the way that it did, this would still have just been a bunch of one-off people's experiences that they were kept to themselves and not included in the larger data set. That's very interesting.
Yeah. So you've got your survey that's out now, and you're probably getting a bunch of responses. What is the plan for the study and how you're going to collect all the data and then what you're going to do with it? And when can we find out whether these anecdotes, all of these little pieces of personal information might tell a story or not?
We are at, Katie, over 100K.
13,000 plus responses today.
Amazing.
And we are hoping this summer to write one, if not two papers on some of the early weeks of data, just so that we can get some information out there as quickly as possible. The thing that's tricky is that we did not anticipate when Katie and I first were writing the IRB for this. There's this little box where you have to put in like about how many participants do you expect. And we put in like 500, thinking that was really ambitious. And we hit 500 within the first couple hours of this survey.
Oh,
so one of the challenges we're facing is that this data set is far larger than we expected. And there's a very interested participant base who feel very urgent about the answers for this.
Yep.
So even with us doing as much as we can to push our many other projects and other paying jobs aside, it still makes it really hard to get this work done. So we were lucky enough, the University of Illinois gave us a small grant to help us pay for some research assistantships. So those will be starting in just a few weeks. So we'll have a few more people joining the team. The National Institute of Health has actually put out a call for supplements for people who already have NIH awards, who could use that data who could leverage that into a supplement proposal to actually study the effects of the COVID-19 vaccine on menstruation. So the other thing that's really cool is our research literally led to the NIH deciding to make money to fund this so that more people would actually study this. So we are, of course, applying for that money,
yes.
But also other people will too, which means multiple people will now put some of their amazing expertise on this question.
Yeah, it sounds like you need to get those R coders doing some automation.
Katie can tell you all about that. She is an R expert.
I mean, one of the things is we knew that there's a lot of experiential stuff that people would want to tell us. So we purposefully wrote the survey with all of these text boxes so that people could share whatever they wanted to about their experience. So things like people experiencing increased breast tenderness as part of their cycle that time, or extra cramps, or comparing it to earlier times. So we have this really rich text data that is a lot more time consuming to go through and really think through than just the ones that are like, I took this survey or this vaccine and it was earlier or later or heavier or lighter or
right.
Right.
Or it's number based or percentage based in some way. Yeah.
Handled with 500. You could have sorted through 500 at the most. But now, what was it? 118,000 something like
113,000.
113,000.
Is there any opportunity for people who might be interested in volunteering to help with the data management in any way? Or for this kind of information, I'm sure there are reasons for ways to keep it secure, but I'm just wondering if there's any room for people to help if they want to.
There are a lot of ethical approvals you have to go through to engage with the data set. And but we do have a great team at this point. It just took a little while. Once we suddenly were like, again, 3 hours in, we went, crap, we just hit our participant goal. Now what? And then our inboxes have been, flooded in. And again, to Katie's point earlier, we really prioritize moving away from a deficit model of science communication and towards a listening model, where we really try to improve trust and transparency by listening. So we're spending a ton of time on email and DMs and things like that, engaging directly with people who have questions and concerns. So that kind of thing is taking up a lot of our time. But we now have multiple grad student RAs, 3 undergrad RAs, a team of postdoc and professors who have amazing expertise in this area. So we are finally at that point where it's like, now we can actually hit the ground running.
What are you finding things as you're listening? I find that really interesting, of not just collecting the data and going, great, thanks a lot, we're going to write our study now, but hearing people. Do you think you might find things in this listening that might lead to new questions, that might inform the way that you approach future questions into reproductive health?
Yeah, some of the things that I don't think we set out with the intention to be able to hear these experiences, but we didn't realize how common they would be, were things around people who were having breakthrough bleeding, who normally don't menstruate. So getting spotting or having a period when they normally don't, including people like trans men, people who are on long-acting reversible contraceptives. So they normally would have menstrual suppression from it. People who are postmenopausal, who are having some bleeding after the vaccine as well. Mm-hmm. And I think if we had set out with a very narrow scope, we only want to hear from people who are not on birth control, who are not perimenopausal, who are not on any sort of hormones at all, we would have missed all of these experiences. And quite frankly, they're the experiences that are probably the most important to address with some of this work, because they're the people who've been left out even more from the existing research. So I think setting out with the listening mode really helped us hear from people who normally don't feel heard. And I know that it's been propagating, and a lot of our survey has been shared and propagating through a lot of different social media spaces that we would normally not know about or be invited to, but sort of being put forth as, hey, here's this experience that you might have. Here's a group that's looking into it.
Yeah. It seems like people who are using hormonal contraceptives or who are on hormones for any reason whatsoever, that if they've been potentially left out of vaccine trials historically, or if that hasn't been asked as to what their status is during the trials, that there could be a lot of information that's really missed, and that there could be reactions or there could be things that would result that we need to know, and we need to know how people are going to respond in different cases. I don't want to keep you up super late. I know it's getting late where you are. I'd love to keep talking about all these various topics, but can
I ask one more question before?
Yes. So let's wrap this up here soon. Yeah.
So I think it's really important, since whenever we talk about women's health and cycles and stuff like that on the show, our listeners are really good at reminding me of terminology. And so I'm just curious if the field of women's health has had the larger conversation about calling it something else. Because I'm often reminded, and I appreciate the reminders because it's, I'm rewriting 30 years of plus years of learning and how to call things what I've called them historically. And when you should talk about people who menstruate, we should talk about women who menstruate, and when you should talk about things in different ways. But when we talk about women's health, it's a group of people that have been marginalized in a very specific way, and we want to give voice and honor that need for women's health and women's health research and women's health support, right? Is that conversation happening, and kind of where is it at? Because I don't want to alienate anyone. I want to use the right words, but I also want to focus on this really important issue that I'm really passionate about.
The term menstruators is one that's been around for quite some time. I first saw it with Planned Parenthood, but I actually have recently, I don't think they actually were the first to start using that term. And then people have also advocated for a more person-first language. So people who bleed or people who menstruate is language that can be useful. I don't know, honestly, women's health is often a public health or a medical field. And we are not public health people or clinicians or medical professionals. And in fact, often our work is actually explicitly critical of those paradigms. So I don't know the conversations that are happening over there, but I would say for us, and Katie can speak to this too, we spent a lot of time really trying to work on the inclusive language of our survey because it was so important to us that we invite and listen to many people who menstruate now, as well as people who've menstruated in the past.
I would say that there is that big public health infrastructure that focuses on women's health, but a lot of that focus isn't actually on women. It tends to be on women as far as they can carry a baby. So we don't actually care about anything other than the reproductive potentiality when you look at a lot of the women's health work as a field. And I think it's really important. The average US woman has between 2 to 3 children in her lifetime. And so we focus on those components of women's health, but we exclude every other menstrual cycle that she has ever had or he has ever had. And we ignore all of the work about people who maybe never wanted to have kids. We don't think about all of the different ways that gendered experiences shape our health. And it's not about the biology of being a woman or having a uterus. It's about the way you move through the world and you experience things differently, and you have different pressures than someone who is not a man. But I think separating out what is biology and what is the gender is really complicated. But if we're going to think about women's health, then I would argue we should be thinking about the experiential gendered effects. And otherwise, we should be talking about things like the actual systems that we're talking about. We don't normally talk about men's health and mean just having sperm and impregnating somebody. That's not what men's health is.
Right.
And so
have you ever read Men's Health magazine? I kind of think it's kind of the major focus.
More about six packs, right?
Yeah, but it's how to attract a mate, and then it's all still reproductive. It's the whole
right. But what about all of the other components? So I think there is a need to have the conversation, but a lot of the overarching structures and the way we've organized the way we do research on certain types of bodies is just really siloed in the US system. I mean, we're going through the National Institute of Child and Human Development for our periods project because that's who's funding it. And so they don't get nearly as much money as an institute compared to other places at the NIH, like the National Cancer Institute. So when we divide people into these body parts or we decide to use social categories to examine health, it's really muddying our understanding in a lot of really important ways.
Thank you both for joining us tonight. This has just been a wonderful conversation, and I want to keep talking with you all night long because this is there are so many more places to go. But I want to respect your time. So as a final question, just can each of you let us know where people can find you and find out more about your work. So Katherine, if you want to start.
Sure. I'm on Twitter at resourceful, SQRL. Most people would say resourceful squirrel, but you're not allowed to have that many letters. And I can be found, I'm not really active on other social medias. So basically just there or through my Washington University website or through Kate's website, which I actually do most of the maintenance on at this point anyway.
Fantastic.
She still does. Like, she's graduated and she still helps me with all that stuff and does all that stuff. So yeah. My lab you can find, which is where you can find stuff from Katie and me and many other people in our lab, is clancylabs.com. My own personal website is kateclancy.com. And yeah, I'm most active on Twitter, where you can find me at Kate Clancy. I've been trying to do more on Instagram because I've noticed there's an awful lot of period stuff happening over there. A lot more there, frankly, than happening on Twitter. So on Instagram, I'm Clancy_Kate.
I will make sure to follow you on Instagram. I'm already following both of you on Twitter, I think. And I hope that all of our listeners do as well. And I can't wait to find out the results of your work, but I will be patient. Have your summers, have your lives, do what needs to be done. But I know there are many people who are interested to find out not just where this particular study goes, but where this ends up going for vaccine health in the future and future studies related to this. So have a wonderful night. Thank you once again. This was just fantastic. Thank you so much.
Thank you.
Thank you.
All right, everybody. This is This Week in Science, and we are going to take a quick break right now before we head into Blair's Animal Corner. And I just want to remind everyone that this is This Week in Science. Yes, it is This Week in Science, the weekly science program that we love to bring you, and we hope that you enjoy as well. And if you enjoy This Week in Science, please consider supporting us. You can head over to TWIS.org and click on the Patreon links over there. Big Patreon button, click on it. It will take you to the Patreon community where you can choose your level of support, $10 and more a month, and we will thank you by name at the end of the show. We've got a great list of people that seems to be continually growing, and I cannot thank all of them enough. And I hope to include you in that list as well. We really can't do this without you. Thank you for your support. All righty. We're going to come right back right now, right? Aren't we? We're going to come right back. We're going to come right back. And it's time for the wonderful, the incroyable, animal-filled Blair's Animal Corner with Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Oh, I have a story about meaningful pauses and how that pause may be dramatic and give extra emphasis to a very particular point, and how that same thing can be employed by electric fish. We pause before we say something to give drama, to kind of give emphasis, but also to give the brain space to share something meaningful. Pauses prime sensory systems to receive new and important information. And so there have been studies on humans looking at this, seeing that human auditory systems respond more strongly to words that come right after a pause. They recognize words better, and that effective speakers tend to insert pauses right before something that they want to have a significant impact. And that this, in fact, from this new study, parallels something you see in electric fish. This is from Washington University in St. Louis. And so this is actually...
That's funny.
Yeah, I know. It's a very interesting coincidence. I didn't even know that. But it was looking at electric fish and how they indeed pause before they give some vital information using electric discharges. This is an electric fish called, it's a type called a moramid. Mormarid. Sorry, take two, Mormarid. And they use these weak electric discharges or pulses to locate prey, but also to communicate with one another. So scientists tracked the banter between fish. They were housed in different conditions. Electric fish that were alone in their tanks hummed along without stopping very much. They produced fewer and shorter pulses than fish that were in pairs. And that fish also in pairs produced high frequency bursts or pulses right after they paused. Then they tried the experiment where they inserted artificial pauses into ongoing communication and found that the fish receiving a pause, the listeners, increased their own rates of signaling just after the artificially inserted pause. They're like, what were you going to say? I had to find out. The pauses were meaningful to the listeners.
Right.
And so they wanted to see what was happening in the brain, which is where this gets extra interesting. They applied stimulation to electrosensory neurons in the midbrain and observed that continually stimulated neurons produced weaker and weaker responses. You're just being barraged with information. But progressive weakness, so this kind of phenomenon is referred to as short-term synaptic depression. So just like if you're doing it over and over, it's going to be weaker and weaker. But when they inserted the pause into continuous stimulation, they saw that the pauses as short as about 1 second, even 1 second pause was enough to allow the synapses to recover from short-term depression, from just getting bombarded with information, and increase the response of photosynaptic neurons to stimuli afterwards. So this is essentially a reset of the brain. And so this kind of plays into, I was thinking about when I was in school. And I would be taking notes and I'd be like listening to the lecturer and I'd be hurriedly trying to keep up. And I'd be so happy when they would pause because I could finish the sentence I was writing. And then I could be a more active listener from that point forward, right? And so that's mechanically what I was doing. But I feel like that's kind of what your brain is doing too, right? And so your brain is trying to process the words coming at you. But if you take a pause, then it can process and like take a deep breath and then catch back up to real time. And so this is something we're seeing across from fish to humans. And so they expect that the same mechanism more or less plays a role in communication in other animals, which would make sense, right?
Yeah, I think we have talked previously about the way that, I think Justin had a story a couple of years ago, actually, about the way that pauses in conversations actually influence how people understand what we're saying. And if you pause too long, then listeners are like, oh, I'm going to go away right now. I'm not listening to you anymore.
My brain's going to drift.
But if you don't pause at all, it doesn't give the brain enough time to process ideas. So it's not just in the communicator, but it's also in the receiver that the pauses are important for the production and also the reception.
That might have been a story I did, or it might have been, I worked with somebody who must have had a really slow processor because they would take the longest pauses. They would be saying something and then silence for several beats. And what was funny is, being me, I would Mad Lib. I would like throw in words. I would finish sentences. But the person never, like, it was as if they were offline. Like they didn't ever hear me inserting the word in the pauses. It was like the weirdest thing.
This is a really interesting point, because this is kind of what I wanted to ask was, is this to increase comprehension, or is it because the communicator is taking a pause to figure out how best to communicate this most important information? And is this a byproduct of that?
Yeah.
And also, if anyone who takes a public speaking course or has any sort of training in it knows that it's better to take a pause than to fill the pause with an or an or a or a right or any of these things. That is an important lesson, because this is exactly what's happening. Aside from it just maybe being annoying, it's giving space to help somebody's processor catch up and take in what you're saying.
Fish do it. Electric fish do it. But I think the important thing for this also is it has to do with the power of the pulse from the electric fish as well. Yes. That the electric fish needs to pause to build up the power.
They sure do.
Blair.
Yeah. Yes.
Let's not have another pause. What's your next story?
Yes. Well, just like you need to be a good orator to be a good performer, also sometimes it helps if you know magic, I guess. So this is a study looking at Eurasian jays and if they can be fooled by a common magic trick. This is from the University of Cambridge, looking at whether Eurasian jays are equally tricked by sleight of hand. Over the past several years, researchers have turned to magic tricks to learn more about blind spots that exist in human perception. And so in this new piece of research, they sought to compare blind spots in perception between humans and animals. And of course, they chose some of the smartest animals, the Eurasian jays, which are a corvid. They're in the Corvidae family. And so obviously they're wicked smart. And they live in many parts of Western Europe, Northern Africa, and India. And they also are known to use trickery to keep other animals from stealing their food. So all that to say, a good place to start to see if they can catch magic tricks. To test their perceptual blind spots, researchers taught 6 of them to peg it on a human fist that had the treat. So then they were doing sleight of hand where the treat could change hands. So they'd show which hand the treat is in and do some sort of sleight of hand. And they'd have to see if the jay was tricked and if they picked the correct hand for the treat. So they used 3 well-known magic tricks, all designed to move an object discreetly from one hand to the other. The first is the palm transfer, and that works by hiding the object in the palm as the transfer takes place. The French drop works by making it appear as if it falls from one hand to the other. So they'll drop it into the other hand, but then it's actually still in the first hand. And then the fast pass is passing the object so quickly between hands that an observer loses track of it. So just passing it back and forth, you don't know which one is it. And they ran the magic tricks on birds multiple times. They kept track of how often they were able to find which one had the treat. And then they ran the same test with human volunteers. Here is the big asterisk. They did this with humans online. So there is a pretty big difference in this one variable here. In the video we're watching right now, the magician is working with the jay in real time in 3D. But their human counterparts were doing it in 2D online. And I do think that is a big difference as someone who really loves magic tricks and used to watch a lot of shows about magic tricks and stuff like that. Having the 2D versus the 3D is a pretty big difference. But regardless, it's a good starting point, I would say, for this research. And so they looked at the data, they compared the birds with humans, and they found that the birds were actually better at keeping track of the treats during French drops and palming, but scored nearly equally on the fast pass. So
first thing is that in studies with birds, we know that birds can smell. They're working with worms that the birds like, and maybe the birds can smell them. So was there any kind of, where's the control for the
really good question,
stuff, right?
Yeah. Really, you have to train them to pick something that isn't a treat for a treat reward, right? That would be the best way to do it, is pick the Lego or something that doesn't smell. And then you get, that's a really good point.
So you have to get them to pick something that has no other contextual cues for, and maybe also, can you do it like a pigeon training where pigeons are trained to tap a touch screen? And can you get the birds to tap a touch screen after watching a video?
That would be great.
Of the palm transfer or the fast pass, which would be similar to the video presentation that the humans would be experiencing. So I think that because they're 3D, like you mentioned, that 3D, 2D paradigm, it makes a completely different experience.
But all that to say, also, corvids are really smart.
I'm not denying that.
Right? This is their whole thing, is being able to hide stuff and trick other animals. And also, a lot of birds have really good eyesight. for fast moving things.
Mm-hmm.
And so I think there is something there that this isn't necessarily a measure of intelligence that we know they're smart. It could just be that they have better equipment to be able to kind of suss this thing out than we have. A little bit more slow to process. So who knows?
Yeah.
We also are better at kind of the abstract side of magic, which requires you to suspend disbelief a little bit and question yourself, which maybe the wild animals don't do as much. There's lots of things here, but I think it is very cool that this research is happening, and I want more of it because I think this
magic
is a really good
birds?
way.
Yes.
Yeah, it's besides just being very fun. I think it is a really good way to suss out something that is difficult to do without sharing language with another species, which is, did you see what I saw?
Yeah. Do you have the same perceptions? Do you perceive what I perceive? And magic is a great way to investigate that. I think their conclusions, I think, were probably right on, with just that the birds are they're looking for different things. These birds are hiding things themselves. They're looking for other trickery. We're not always looking for trickery in what we're looking for. Magic. Yeah, and in the chat, there's the question. Kev B is asking, what's the refresh rate of birds' eyes? And birds do actually see at a higher frequency than other vertebrates.
Yeah.
And some birds see even faster. They have a faster refresh rate than other birds even. So there's from the Audubon Society, the pied flycatchers in Europe can detect cycles at 145 hertz, which is about 40 hertz faster than anything else. So
there you go.
So birds.
Speedy vision.
Speedy. You can't trick them.
No.
You got to be faster than fast.
No trips to the magic castle for the Jays. Wouldn't have any fun.
No fun at all. Oh my goodness. This is This Week in Science. Woohoo! You're here with us. Thank you for joining the show. And if you'd like some awesome TWIS merchandise, please head over to twis.org and click on our Zazzle link. Blair made some new cool TWIS jogger pants. We've got some cool tank tops for summer. There's some really neat stuff in there in our Zazzle store, so please go check that out. Hey, Justin, what else you got for us?
Conservatives more susceptible to believing falsehoods. In a new segment that I just created for this story called Did We Really Need a Study to Tell Us That? It's not as good as the
making up the tag music.
Wow.
Yeah. Conservatives, politically conservative folk, are less able to distinguish truths from falsehoods than liberals. Caveat, as long as they think the content is political. This is actually, this at first is just sort of like, haha, knew that. But at the other hand, this might come in handy for future trying to convince people of things. So the study had a few elements to it. It was done over 6 months, a year. It was a year ago, but it was a 6-month study with 1,200 people. Each week, they would give them 10 real stories and 10 fake stories that were sort of trending in the social media and in the news media. And they would sort of have them evaluate it. So researchers found that both liberals and conservatives, this is all in the United States, tended to believe claims that conformed with their political views. Not too surprising, right? But in doing so, this more often led conservatives to accept falsehoods and reject true stories. Researchers also asked participants a series of questions, 20 statements that were based on those stories. In the end, they had 240 statements then each. Different beliefs are pretty stark. A true statement: poor conditions in several Texas migrant facilities, including extreme overcrowding and serious health risks, showed 54% of Democrats correctly said that the statement was definitely true, as opposed to only 18% of Republicans. false statement for a political target, Hillary Clinton colluded with Russia, selling 20% of U.S.'s uranium supply to Russia in exchange for donations to the Clinton Foundation. That was a fake story. 2% of Democrats actually thought it was definitely true. 41% of Republicans thought it was true. The story was totally false. One of the major issues identified in the story is the way these widely shared truths and falsehoods have different implications for them. So a separate group of people who were recruited online were surveyed to do a rating system to determine whether the claims made in any of the statements of the stories would sort of politically favor liberals, politically favor conservatives, or if they were just neutral. They were just a news story. So 2/3 of the high engagement true stories were characterized as benefiting liberals. Only 10% of accurate claims in those were considered beneficial to conservatives. So part of it is also, if you're conservative, most of the information that you're getting fed, it seems like, contains falsehoods. And there's very little accurate information being presented to you as part of your political ideology. So here's where it gets very interesting, though. When they looked at the conservatives and liberals were equally good at detecting truths and falsehoods when the stories were politically neutral. When the stories were labeled politically in advance and they said, hey, these are going to be political, the conservatives didn't improve. They stayed the same, believing a lot of the untruth ones. But the liberal side sort of got better. Once they knew it was political, they could suss out some, even if they agreed with their political ideology, they could sort of still suss them out as not being true once they realized that they were being, specifically politically targeted. But the fact that when it was just neutral information news stories, that they could equally detect which was true and which wasn't, kind of showed a truth bias on things that they believe is connected to their ideology amongst conservatives. This was done at Ohio State University. Kelly Garrett was the co-author and professor of communications there at that university, saying, that's a problem because some of the claims are outlandish. There should have been no ambiguity about whether or not they were true, he said. We show that media environment is shaping people's ability to do this very basic fundamental task. Democracy depends on people being able to tell the difference between what is true and false, and it falters when people have difficulty agreeing on what is real.
Yeah. I mean, if truth and reality are debatable or we're living in different ones, how can we have a common democracy? Democracy is the shared system. It breaks down. Yeah.
So there's a couple of things that it's pointing out. A couple of things it's pointing out is that, first of all, it's really tough for conservatives to have a good compass for what is a truth story and what is a false story, because the majority of the diet that the conservative media is feeding them tends to be false and misleading.
Fake. Yeah.
The other thing it tells us,
contain false and misleading information, maybe nuggets of truth, but then, yeah.
The other thing that this tells us is that if you can separate something like global warming from political ideology, if you could separate something like the response to a pandemic from political, that they would be right there with the liberals and being able to tell what's a real story and what's a fake story. If it's just news, they have the same rationing ability. It's just they get this weird truth bias for stories that they think is conservative.
So now we have to figure out something else to get people paying more attention and figuring out when they're being manipulated, because that's what's going on.
Oh, God.
Did you have any more stories, Justin?
Well, there was one. I guess it doesn't matter. It doesn't matter. It doesn't matter. There's a team of researchers at the University of Aveiro and University of Porto, both in Portugal, University of Birmingham in the UK, found that for humans, and this is also reminding me of our guest a little bit, the brain and testes have the highest number of common proteins. In their paper published in the journal Royal Society Open Biology. The group describes the huge amount of protein similarities between the two tissues. And immediately made me wonder, did they even study vaginas? No, I wonder if that was even...
Why bother?
I mean, that's a big question, right? I mean, or not vaginas. Let's not, if not vaginas, then the ovaries.
Yeah, it would
because
be
if they're
ovaries,
talking
yeah.
about...
I don't know all the vagina parts. Don't
The ovaries.
Yeah, that's the
If you're talking about
problem.
the testes, let's
I
talk
went
about
to
the
school in
ovaries.
America. Is that what
Compare
is that
them.
the equivalent?
Yes.
Okay. Well, you learn something new.
Oh my
every day.
god.
I'm
Really?
just kidding. No, I'm just kidding. But they say that it was the
I'm just going to keep my mouth shut on
the
this.
suggestive finding was
parallels,
not
though.
surprising, considering that proteins from both organs consume high amounts of fuel, one to process thinking, the other to produce millions of sperm every day. Again, the menstrual cycle is probably doing a lot of work that's not being covered in this, so it sort of also fits with. They also note that testes and nerve cells are both involved in moving material created inside of them to an outside environment. Sperm cells move fertilization factors, and neurons move neurotransmitters. So they also have some similarities there.
Yeah, I'd love to find out where there are other similarities, but that's interesting. The highest proteinaceous similarities. You know what might be similar? It's like, can you really tell the difference between a black hole and dark matter?
I know, I can't.
Really?
Now, unless I get really close, but then it's too late.
That is too late, right? So this is a very interesting question being asked by astrophysicists right now, publishing in the journal Monthly Notices of the Royal Astronomical Society Letters. A group of researchers at the International Center for Relativistic Astrophysics are suggesting that the supermassive black hole, Sagittarius A, that lives at the center of the Milky Way galaxy, is in fact not a black hole, but a mass of dark matter.
Wait, what?
Yeah! So, I mean, the question really is, like, if you have a big mass, whether that mass is compressed down and imploded and sucked into inner space like a black hole, or whether it's just a big mass that's got the same mass-ish as a black hole, wouldn't you really be able to tell if it had the same Schwarzschild radius limits, if it had the same gravitational effects, if things acted in the same way? What they're saying their evidence is, they looked at a bunch of star clusters, and everybody's been like, oh, look, they act gravitationally correct. Everything, it's like predicted for a black hole, so it should be a black hole. Well, they looked at a gas cloud that got really close to Sag A, and they said, okay, that should have been devoured. Should have just been eaten right up by that black hole, and it wasn't. It passed right through. Yeah. So is it not a black hole? Is it just a mass of dark matter? And if it is a mass of dark matter, what does that mean for black hole formation and big galaxies? And could it be that there is a certain point at which enough dark matter accumulates that it creates a black hole finally? There are so many questions and so many things we don't know, but this, of course, will be debated within the astrophysics community.
I mean, do black holes even exist? Who knows?
Who knows? Our math says they do.
Yeah, no, they do. But
we took a picture of one.
The argument would be that you have a much larger. You don't have a singularity. So you have a larger area that's containing this mass that hasn't collapsed on itself. And then what would be able to do that with that much? I guess maybe the dark matter could do that.
Yeah. And I hadn't realized it, but researchers are calling the stuff that would be in dark matter now darkinos.
No, don't give it a particle-y thing yet.
They're giving it a particle-y name, darkinos.
No, you
It
can't
would
do that.
belong to the same group as fermions. Yeah, I don't know about that. But Anyway,
Okay.
moving on from dark matter. Who here wants super hearing? Do you want to hear bats? You could hear the little high-pitched, super high frequency, 20,000 hertz sounds that bats make. Do you want to hear that?
Yeah, I'd also just like my hearing back from before I went to too many concerts. That also would be good.
Well, yeah, there is that as well.
Yeah. I just get my original hearing back. But yes, bat hearing would be great also.
I would like that original hearing back as well. Researchers have published in Nature in scientific reports this week superhuman spatial hearing technology for ultrasonic frequencies. They have created a wonderful device that you strap to your head. And as you strap it to your head, then it can it can hear the sounds that you can't. And then that is connected to computer and can then filter the sounds, turn them into the frequencies that we are within our audible range, and then give us a sound that we can hear and that is directional so that you can pinpoint where it comes from. All of this processing happens within about 44 milliseconds, which is just shy of where we lose our spatial resolution. So this device, it's a ball.
It looks like he has antenna. A single antenna.
Yeah, it's like an apical antenna, right? It's just a single antenna that is wired, sticks out from a wire from the top of the head and is attached to a headphone array. And they put a number of volunteers in an enclosed audio room, a quiet room where they were played these sounds. And they were able to prove of concept that this device could allow people ultrasonic hearing. You're not really hearing ultrasound. They're just turning the ultrasound into a sound that you can hear. But could be useful for people who are trying to locate high-pitched frequencies and the sources of those high-pitched frequencies. Where'd that come from?
So it's kind of like turning a black light on to see UV, right? I mean, you're basically adjusting what you're perceiving to perceive something that other animals can perceive on their own.
They can perceive it on their own.
Perceive.
Yeah. It's just, but using technology to enable that perception. And the researchers say that in addition to just being kind of cool and allowing this perception that we wouldn't normally have, there are other possibilities of real world applications. The researchers say finding sources of ultrasonic sound is useful in situations like finding leaks in pressurized gas pipes. Minor pipe leaks often produce strong ultrasound emissions that aren't detected by normal hearing. It can also allow us to spot the sound source quickly. Also, damaged electrical equipment emit ultrasound, and so the device could be used for locating faulty equipment in places like data centers. So there are some real world uses for more than just bat researchers. Okay, I want everybody to look. This study is going to lead everybody to look into their eyes. Look into the eyes of people around you. How big are the pupils in those people? How big? Do you ever notice how big people's pupils are on a regular basis? Aside from, it's really dark in here and your pupils have enlarged. Or concussions. I'm checking your pupils for concussions. Yeah. Well, there is a study out this week that suggests that our pupil size is correlated with intelligence.
Do they really vary that much, though?
So pupil size does vary. Our pupil size varies all the time. And so the researchers looked at another number of studies that had been done previously to kind of
done by somebody with big pupils.
Maybe it's not. So the pupils can normally range from around 2 to 8 millimeters in size, and the iris is responsible for controlling the pupils. And so there have been a number of studies that test fluid intelligence and working memory. And while the studies have been done, researchers have noticed that there have been differences. They have people staring at screens for a long time and doing eye tracking, and they have collected data on pupil size, and they noticed this correlation. So they started looking for a more specific relationship, because our pupils are also related to a lot of emotion. So how, I guess, attentive you are. It's been used in lie detector tests, whether or not your pupils change size as you get. Right. Well, yes and no. Yes and no. You can train yourself out of it if you know to be train.
The test itself is unreliable, unscientific.
But your pupils are a sign of arousal, and we do know that pupils opening and being a little bit more dilated, that occurs when people are attracted to each other. There is a connection between human behavior and pupil size. And so these researchers found that there is the larger the baseline pupil size, not related to how much it varies all over the place, but the larger the baseline, that's correlated with a greater fluid intelligence, better ability to control your attention, and also working memory capacity, but not quite to as much of an extent. They also connected it to an area of the brain called the locus coeruleus, and this is in the upper brainstem, and it's kind of an entry point to a lot of other areas in the brain. It regulates a bunch of processes like perception, attention, learning, and memory, so it's connected in that way. And so they need to really figure out this relationship more, but pupil size is related to activity level in this brain nucleus. So there's stuff going on, and they don't understand it completely, but there may be a connection between.
So do you want
the size of your pupils?
You want a bigger pupil to be smart? Is that the smarter pupil, or is it the little?
Yeah,
pupils?
You want a little bit bigger. You want a bigger pupil baseline. You don't want to be dilated all the time, because then you're going to just have issues. But but it's interesting. They did also find that there is a negative correlation between age and intelligence. So as you get older, it's like your pupils get smaller. And so there's aging affects your pupil size, or is it affecting your intelligence? I don't know. But
so
anyway,
that's what I was thinking.
There are some other factors that need to be delved into.
You need to control this for specific subsets. You need to look at pupil size across women, then you need to look at pupil size across men, and then you need to look at pupil size across ages, and then you need to look at pupil size across iris color, and then you need to, there's so much going on.
It's correlation.
Yeah, you need to look at it across people with an astigmatism, because now you're also talking about a physical.
What if it's a sunny day? What if it's a poorly lit room?
That's not what they're talking about.
But there are a lot of factors that go into the shape and size and features within your physical eyeball.
All right, I have one final study for the show tonight, and turns out if you starve yourself, your memory's going to be better. Not exactly starving yourself. So in this study, researchers looked at intermittent fasting versus caloric restriction. Both of them were matched to an average about 10% dietary caloric reduction. And they found that after 3 months, this is of course not in humans, in mice on the intermittent fasting had an increase in adult hippocampal neurogenesis. That means more brain cells in the hippocampus in the adults than the caloric restriction group, and they had better long-term retention of tasks that they had been learning. They did some analysis of what was going on in the hippocampus, what was getting turned on molecularly. And there's a gene, a longevity gene, that gets turned on in the intermittent fasting that does not get turned on with caloric restriction, called clotho. Clotho gets turned on, upregulates the neurogenesis, and potentially facilitates long-term memory consolidation. Who knows? Intermittent fasting. 1 day on, 1 day off, 1 day on, 1 day off. Starve yourself, you will remember things if you're a mouse.
But you also might have liver damage or other problems, so Keep that in mind.
Take that into account. Ta-da.
Yeah, intermittent fasting in 10 years, we're going to really know if it was a good idea or a really terrible idea. That's like Atkins, right? Was a thing that was all the rage, and now everybody knows it's actually really bad for you. So it's something that I'm very curious to see what the science says when intermittent fasting is done. It's interesting. There's a potential for it to have some good side effects as well.
Yeah. What is it going to be doing? I could almost suss out a mechanism within the microbiota of the microbiota being like, they haven't sent us anything for a while. Do you think, did they forget where food is? Let's go send them some reminders of where food is. Let's boost that memory system so it can remember where it put food or where the last time it saw food.
Except I can tell you when I am hungry, I cannot focus. So I feel like that's the hard part here is brain need food.
You're also going to be, if you're hungry, you're going to be more motivated to find food and remember food. It's a survival tactic. So if these are food-related tasks, which most definitely they were, you're talking about a Morris water maze.
Even if they're not like specifically food-related, that's what the brain is built for. Your brain is mostly built to feed you, to tell you to go find food, get food, feed yourself. All the other things that we're doing are just hijacking a system that was there just to find food in the first place. That's all it was there to do.
And then reproduce, right?
Yeah.
Find food, reproduce. Find food, reproduce, sleep. Find food, reproduce. Find food, reproduce, sleep.
Food.
I can't say that fast. Find food, reproduce, sleep. Find food. You try it. It's hard.
I shan't.
Yeah. Well, we're not mice, but of course, this is going to lead the researchers to looking at more deeply. Klotho has already been identified as a longevity gene. Is this the kind of gene that could be targeted with a drug, with a medication, with something, gene therapy, who knows, to enable better memory into old age? Is this something that we'll find maybe we don't have to fast intermittently as we age to keep our memory fresh? Maybe we can just pop a pill. Or, as Justin is suggesting, update our microbiome. Or, maybe there are things that we can do to give our body the messages that it needs to keep us healthy and stronger, longer. Have we made it to the end of another show?
I do believe we have.
Oh, here we are.
So many stories, and we made it. We did it, everyone. It was a good time. I would like to say thank you. Thank you, everyone. Thank you for listening. Thank you all for joining us. Thank you to our guests this evening, Doctors Kate Clancy and Katherine Lee, for joining us to talk with us about women's reproductive health and vaccines. It's really an interesting area of study that I hadn't considered in quite the way that they brought it to us this evening. So it's always nice to be struck by a new way of thinking about something. Shout outs to Fada for your help with social media, with show notes. Gord, thank you for manning the chat room. Thank you to everyone who's in the Twitch chat room right now. Hope everyone's having a good time in there. People in our Discord, you in our Discord talking? Thank you for joining us in Discord also, and in YouTube in our chat room, and on Facebook in our chat room. Thank you for being with us during the show. Thank you, Identity for recording the show, and thank you, Rachel, for your wonderful assistance. I would also love to thank our Patreon sponsors for their wonderful support of TWIS. Thank you to Pierre Velazarbe, Ralph E. Figueroa, John Ratnaswamy, Kira Carl Cornfield, Melanie Stegman, De Kramster, Karen Tozzi, Woody MS, Andre Bissett, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Shu Brew, Don Mundus, Stephen Alberon, Daryl Marshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Joshua Fury, Shauna Nina Lamb, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard Brendan Minish, Johnny Gridley, Kevin Railsback, Flying Out, Christopher Dreyer, Mark Mazzaros, RDM, Greg Briggs, John Atwood. This profile name is hilarious in the context of some other podcast. Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Matt Sutter, Philip Shane, Kurt Larson, Mountain Sloth, Jim Drapeau, Sarah Chavez, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Stanton, Paul Disney, Patrick Pecorar, Tony Steele, Ulysses Adkins, Brian Condren, and Jason Roberts. Thank you for all of your support on Patreon. And if you want to support us on Patreon, you can go to twist.org and click on the Patreon links. On next week's show,
we will be back Wednesday, 8 p.m. Pacific Time, broadcasting live from our YouTube and Facebook channels and from twist.org/live.
Hey, if you want to listen to us as a podcast, just search for This Week in Science where podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twist.org, and you can also sign up for a newsletter.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into a very pregnant pause. Forever.
no.
You can also ping us on Twitter, where we are at Twist Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview haiku that comes due in the night, please let us know.
I thought you were like trying to burp or something. We'll be back here next week, and we hope you'll join us again for more great science news.
Oh, and remember, if you learned anything from the show,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we said, then please just remember it's all in your head. 'Cause it's This Week in Science, This Week in Science, This Week in Science, 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 This Week in Science, This Week in Science, This Week in Science, 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 This Week in 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 Science, This Week